welcome back. Today we are going to dive into some essential tools in programming and the compilation, the interpreter, assembler, and compiler. These terms are often used in programming, and understanding the differences will give you a strong foundation for how code gets executed on your machine. First, let's talk about the interpreter. So, interpreter is similar to the translator. See, it is similar to the translator, but the add-on point on this interpreter is that it translates and executes at the same time, and it works line by line. Okay, so whenever your code is being interpreted, the whole source code is being translated and executed line by line at a time. See, whenever your high level language code is being given as an input to the interpreter translates and executes each line one at a time. So the first task of this interpreter is to translate your code into the machine level language and then execute each line at a time, and gives you feedback on the each line. Okay, so if an error occurs on the first line, the translation or the execution stops at the very first line of the code. So it is very great for testing and debugging, because debugging involves execution of the each line. As we are doing the execution and translation of the each line, it's going to be slower. So examples of the interpreter languages are Python, JavaScript, and Ruby. Okay, so our next one is assembler. Assembler is one kind of translator, as we have discussed in the very first video, that types of translator were assembler and the compiler, right? The only thing that is different in assembler is that it takes the assembly language program or the code as an input and gives you the machine code. Machine code is nothing but a binary code that our computers processors can execute, right? So it is used when speed and control over the hardware are crucial, because whenever we are having a assembly language, so it will not take much time to convert it into the machine code, as compared to the compiler, which takes the high level code and translates it into the machine code. Now, in the earlier videos we have already seen how the compiler works. So unlike an interpreter, the compiler does not translate line by line as a program runs. Instead, it takes the entire code and translates it into the machine code all at once, creating one executable file. This executable can then run be independently, which makes the compiled program faster to execute than the interpreted ones, right? So the languages like C, C++, and Java uses the compiler, and it also performs the checks, optimization, and the error detection we have already seen, which is super useful in creating the efficient and reliable code, right? So now let's see the comparisons between three of them. We'll go through this table and you will understand how they are being compared in what terms. Now, whenever you are asked the question for writing the differences between the interpreter and assembler, or the assembler and compiler, or the compiler and interpreter, you can use this table. Okay, so the first feature will compare is its primary function, right? So whenever you write the differences, you might be writing the definitions and the meaning of that particular things at the very first time. Okay, so it's better let's start with the primary function only. So the primary function of the interpreter is to translate and execute the source code one line by line. Okay, so this is the most important thing, that is it translates plus executes, and that too line by line. Okay, this what assembler does is assembler converts the assembly language to the machine code, and compiler translates the entire code into an executable file. It translates an entire code into the executable file. See, you can draw the diagrams also here. See what interpreter is. So you can write this as, see what interpreter is. So it takes high level language, as an input and executes and translates line by line. Okay, so you can just write here translates plus execute, and it converts it into the, it gives you feedback at each line. You can draw like that. Okay, feedback at each line, as I have already drawn here. You can just draw the similar thing, but in a concise manner, right? And same way for the assembler. This is our assembler. Its primary function is to take the assembly language code as an input. So this is an assembly language code as an input, and give you the machine code, right? Same way what compiler does is, compiler takes the high level language as an input and converts it into the low level language. Okay, so you can draw diagrams also. You can draw diagrams here actually. Okay, so second thing is see, its primary function is translation, right? So what is the style of its translation? So this is translated line by line. This is translated one step translation to the machine code. Okay, whole the assembly language code is translated to the machine code, and in the compiler whole code is taken at a time and translated into an executable file, right? So that when we are talking about execution speed, interpreter will be slowest because it executes and translates both at a time, and that too line by line, right? And this assembler will be very fast, and compiler will be fastest because compiler does nothing but converts whole code into the machine language code and just reports the errors it encounters, right? Then error detection. So see, whenever an error is detected into the interpreter, it stops. Okay, whenever it encounters its first error. In assembler, it has minimum error checking because it already has the assembly language code. Okay, then in the compiler it detects all error before execution, as we have already seen in the first introduction of this compiler. Then typical use cases of this interpreter. See, the interpreter is used where we want to do the rapid development and debugging. Okay, so it is very much important when debugging is involved. Whenever you are making some software product or some standalone project, then this debugging is important when you are checking or testing your functionalities, okay, whether it is working or not. Then assembler is used in the low level programming, and this compiler is used for the performance critical application. So the example languages, the interpreted languages are Python, JavaScript and Ruby, and the assembler's example languages is assembly language, and compiler is C, C++ and Java. And what is the kind of output that we get in the interpreter is, it does not give any specific output, right? It just execute code and translates it. If there is an error, then the execution stops. And similarly in the assembler, what we get an output as a machine code, which is a binary code where the computer's processors can execute and understand, right? And in the compiler we get a executable file which can be executed on any platform, that is platform independent, right? See, symbol table management. Yeah, I have already told you in the phases of the compiler that there is some symbol table management that supports the phases of this compiler. So to support the phases of a compiler, a symbol table is managed. See, symbol table is nothing but a data structure which stores the information about the identifiers. We have broken down the source program into the tokens in the first phase of the compilation. That was our lexical analysis, right? So that tokens are being stored into the this symbol table management. Okay, symbol table, which is nothing but a data structure. So it stores the identifiers which are used in the program. Then it stores the information about the attribute of each identifier. Okay, for example, you can say the type, then its scope, then the storage, etc., right? Then it also stores the information about the subroutines. So this was the wrap of the chapter 1. So today we explored the key concepts including the assembler, interpreter and compiler, and we broke down how they work together in the programming. So with this we have completed all the topics of this chapter. So if you have any questions or need clarification on anything, please free to drop a comment. I am here to help you all. So in the next video we'll be kicking off chapter 2 with a deep dive into the lexical analyzer. We'll look at how it plays the essential role of breaking down code into tokens and setting the stage for the rest of the compilation process. So if you're curious about how the compiler starts reading your code, make sure to join in and stay tuned everyone. See you in the next one. Thank you.